students, in the previous lecture I have discussed about inventory simulation. In this lecture I am going to take another interesting problem, that is called waiting line simulation. So, the agenda for this lecture is, assume that a bank is having only one ATM. When there is only one ATM, so the bank manager want to fix certain service requirement. What is the service requirement? Meeting the service requirement of the waiting time for a customer should be less than 1 minute. Okay. What the service requirement? The bank manager or the vice president of the bank decides that my customer should not wait more than 1 minute. For that purpose, we have only one ATM. If I have only one ATM, can I meet this service requirement? That answer we are going to provide with the help of a simulation model. Waiting line simulation, static simulation. The simulation models discussed so far have been based on independent trials, in which the result for one trial do not affect what happens in the subsequent trials. For example, in the previous class we have discussed about the inventory simulation. So, the result of one trial will not affect the subsequent trial. In this sense, the system being modeled does not change or evolve over time. So, the time is not important factor there, it is independent of time. Simulation model such as these are referred to as static simulation models. What is the meaning of static simulation model? The outcome of one trial will not affect the outcome of another trial. But in this class we are going to discuss about the dynamic simulation. What is the meaning of this dynamic simulation? The outcome of one trial will affect the outcome of another trials. The model which I have discussed so far is called Monte Carlo simulation. In the Monte Carlo simulation, it is independent of time, but in this class we are going to discuss about the dynamic simulation. So, the waiting line simulation. Now, we shall develop a simulation model for a waiting line system, where the state of the system, including the number of customers in the waiting line and whether the service facility is busy or idle or changes or evolves over a time. So, we are going to discuss about the dynamic simulation. What is the problem? As I discussed in the introduction, a bank will open several new ATM facilities during the coming year. See that there is a bank, the people are waiting. The number of people using an ATM is a variable over 24 hours work day. A concern is that during busy period people will have to wait as the ATMs under use. This concern prompted the bank to study flow of people as a waiting line. The company's vice president wants to determine whether one machine at each center will be sufficient. You might have seen in front of adjacent to bank there may be ATM center will be there, sometimes there will be one machine or two machines. At present assume that the bank has only one machine. So, the service guidelines were established stating that the average delay waiting for people should be no more than 1 minute. So, the service requirement is the customers of that bank should not wait more than 1 minute. That means, they can wait maximum 1 minute. But we have only one machine. So, the question is whether we are able to achieve this service requirement, that is waiting line should be less than 1 minute with the help of this one machine. So, that is what we are going to suggest. So, let us show how a simulation model can be used to study the waiting time at a particular ATM center. Note that each person, the customer, can be viewed as a flow unit passing through the system in this example. What is the requirement? The waiting time of customer should be less than 1 minute, but we have only one ATM. Now, we are going to test whether this service requirement can be achieved or not. If it is not able to achieve, what we have to suggest? We should go for 2 ATM in the same room. Now, the customer arrival time, that is called inter arrival time, that is one of the input for the simulation model. So, one uncertain input to the simulation model is the arrival time of customers to the ATM. In waiting line simulations, arrival times are determined by randomly generating the time between successive arrivals, referred to as the inter arrival time. So, we are going to generate inter arrival times. So, we are going to assume that the inter arrival time follow uniform distribution. So, the inter arrival times are assumed to be uniformly distributed between 0 and 5 minutes as shown in this figure. See, arrival pattern follow uniform distribution. See, minimum 0, maximum 5, and the average inter arrival time is 2.5 minutes. That means, the arrival between one customer and another customer, the average time is 2.5. Sometime the customer may come in 1 minute also, in 4 minutes also, but the average inter arrival time is 2.5 minutes. With R denoting a random number between 0 and 1, an interval time for 2 successive customers can be simulated using the formula. This formula we have already shown to you. I will show you what is that formula, simulated by for generating values from uniform probability distribution. So, what is that formula? That formula is A plus R into B minus A. Here A is this 0, B is this 5, R is random number between 0 and 1. So, when you substitute A equal to 0, R this we have to generate 5 minus 0. So, it will be 5 R. So, inter arrival time is 5 R. A uniform probability distribution of inter arrival time is used here to illustrate the simulation computations. Any inter arrival time probability distribution can be assumed. So, instead of uniform distribution, you can assume arrival pattern may follow Poisson distribution also, or it can be exponential. But in this problem, we have taken that inter arrival time follow uniform distribution. And the fundamental logic of waiting line simulation model will not change. You can assume any type of distribution for the arrival pattern. So, the logic of simulation will not change, but in this problem we are going to assume that the arrival inter arrival pattern follow uniform distribution. The next input is customer service times. Here the customer service time means, suppose when a customer enter into the ATM center, some people may withdraw money, some people may check the balance, some people may change their PIN, like that there are different service they can take. Okay. So, here another uncertain input in the simulation model is usage time, which is the time it takes for a customer to use the ATM. There may be different purpose, some people may use it for withdrawing money, some people for checking the balance and so on, but that time is going to follow normal distribution. Okay. So, past data from similar ATM center indicate that a normal probability distribution with mean of 2 minutes and a standard deviation of 0.5 minutes as shown in figure, that figure is there in the next slide, can be used to describe the usage time, that is the service time. As discussed, the value from a normal probability distribution with mean 2 and standard deviation 0.5 can be generated in Excel. So, what equation will you use? This also we have discussed, norm INV rand, then mean, then standard deviation. So, using this function we can generate a number which follow normal distribution rand. So, here it is mean is 2 minutes and the standard deviation is 0.5 minutes. What is this? The customer service time. So, in the simulation model, what are the uncertain inputs? Inter arrival time and service time. Inter arrival time follow uniform distribution, service time follow normal distribution. Here the controllable input is number of ATM. Now, we are going to work out this model. If there is only one ATM, whether the service requirement of waiting time less than 1 minute can be achieved or not. If it is not achievable, then we have to suggest for 2 ATM. Now, the simulation model. What is the simulation? There is a number of ATMs. At present we are having only one ATM. What are the other inputs? Inter arrival time is one input and the usage time is another input. What is the operating characteristics? So, the average waiting time should be less than 1 minute. Okay. That is one of the operating characteristics. We are going to test by having one ATM this operating characteristics, that is average waiting time less than 1 minute, can be achieved or not. So, the flow chart shows, first we initialize the simulation model, I equal to 0, arrival time is 0, completion time is 0, one new customers are entering, then we generate inter arrival time, then how we are getting arrival time plus inter arrival time. Then if is arrival time is greater than completion time, okay. If it is yes, the ATM is idle. So, customer I can begin usage immediately. When this will happen? If the arrival time is greater than completion time, because one customer already left, the ATM is free. When that situation will occur? If the arrival time is greater than the completion time. If it is no, the ATM is busy. That means what? Customer I, small I, this is I, must wait for preceding customers to complete the usage. Okay. Then we will be finding the waiting time, starting time minus arrival time. Then we will find the generate usage time. What is the completion time? Starting time plus usage time. What is the system time? Completion time minus arrival time. This is the flow chart for the simulation. ATM is idle or busy. How do you know that the ATM is idle or busy? The arrival time for the new customer must be compared to the completion time of the preceding customer to determine whether the ATM is idle or busy. See that if the arrival time of the new customer is greater than the completion time of preceding customer, the preceding customer will have finished usage prior to the arrival of the new customers. In this case, the ATM will be idle and the new customer can begin service immediately. Okay. For example, see on 30th minutes, one fellow has used the ATM. So, the next arrival time is say 32. What has happened? After 30th minutes, that ATM is free, but the next customer is entering only on 32nd minutes. So, the 2 minutes this ATM will be idle. In such cases, the usage start time for new customer is equal to the arrival time of the new customer. That means when the ATM is idle. However, if the arrival time for the new customer is not greater than completion time of the preceding customer, the new customer arrived before the preceding customer finished the usage. In this case, the ATM is busy and the new customer cannot begin until the preceding customer completes the usage. So, that means what? Suppose see 32nd minutes, somebody has used ATM, the next customers arrives on 30th minutes, because up to 32nd minutes the ATM is busy, but the next customer has come into 30th minutes in a continuous scale. So, 2 minutes, okay, 2 minutes the new customer has to wait, that means that 2 minutes that ATM is busy. So, in that the start time for the new customer is equal to the completion time of preceding customer. Even though he comes on 30th minute, he can start the getting the service only on 32nd minutes, because then only that ATM will be busy there, the ATM will be free. Now, I am going to explain what is the waiting time and the customer completion time. Note that the time the new customer has to wait to use the ATM is the difference between the customer's service start time and the customer arrival time. At this point, the customer is ready to use ATM and the simulation run continues with the generation of customer's usage time. The time at which the customer begins usage plus the usage time generated determine the customer's completion time, which then becomes the earliest start time for the next customer that arrives. So, this concept with the help of a numerical example I will explain in the next slide. Then total time the customer spent in the system. Finally, the total time the customer spent in the system is the difference between customer's usage completion time and the customer's arrival time. At this point, the computations are complete for the current customer and the simulation continues with the next customer. The simulation is continued until a specified number of customers have been served by the ATM. In our example, we are going to consider 1000 customers. Dear students, now I will explain the concept of simulation with the help of some numerical example. So, I have considered 10 customers. See, the first column is 10 customers, second column is inter arrival time, which I have randomly generated, which follow uniform distribution. The next column is arrival time. The arrival time I have written in a continuous scale. After that, service start time, then it is waiting time. What is the waiting time? Is the difference between service start time and the arrival time. Then usage time 2.3, that I have randomly generated, which follow normal distribution. Then completion time. What is the completion time? Completion time is service start time plus usage time, that is 1.4 plus 2.3, that is our completion time. Then what is the time in system? The time in the system is completion time minus arrival time. So, 3.7 minus 1.4, okay, that is our time in system. Now, the first customer entered into the ATM, he will use up to 3.7 minutes. Now, the second customer, we have this number 1.3 we have randomly generated. So, 1.3 plus 1.7 he entered into the system, his arrival time in continuous scale is 2.7. You see that the first customer is still using up to 3.7 minutes, but the second customer has arrived at 2.7 minutes. Here what he has to do? The second customer has to wait. So, even though he arrived at 2.7 minutes, his service will start only at 3.7. So, what is the waiting time? Service start time minus arrival time is 1. Okay. So, his service started at 3.7 minutes, he will use it for 1.5 minutes. So, he will complete the service at 5.2 minutes, that is 3.7 plus 1.5. What is the time in system? Completion time minus arrival time, that is a 5.2 minus 2.7. Then the third customer, inter-arrival time is 4.9. So, arrival time in a continuous scale is 7.6. You see that the first customer left the ATM at 5.2 minutes, not the first customer, second customer. So, third customer is entering at 7.6. So, that means what? The 5.2 minutes onwards, okay, the ATM is idle. So, third customer, he need not wait, directly he can get the service at 7.6 minutes. So, there will not be any waiting time. He will use it for 2.2 minutes. When he will complete the service at 9.2 minutes. What is the time in the system? 9.8 minus 7.6, that is 2.2. Now, you see the fourth customer, inter-arrival time is 3.5. So, 3.5 plus 7.6, it is 11.1 minute, but the ATM is free from 9.8 minutes onwards. So, he will directly enter into the service. So, service start time is 11.1 minutes. So, there will not be any waiting time. He will use it 2.5 minutes. When the ATM will be free up to 13.6, after 13.6 minutes the ATM will be free. Okay. So, time in the system is 13.6 minus 11.1, it is 2.6. Now, you see the fifth customer. The fifth customer arrival time in a continuous scale is at 11.8 minutes. How we got this 11.8? 0.7 plus 11.1. But the fourth customer still is using the ATM up to 13.6 minutes. So, this fellow comes early, but he will get the service only at 13.6 minutes. So, how much time he has to wait? 13.6 minus 11.8 minutes, 1.8 minutes, customer 5 has to wait. So, he will use it for 1.8 minutes. So, he will come out of the ATM on 15.4 minutes. So, how much time he is spending in the system? 15.4 minus arrival time, that is 3.6. Now, you see the sixth customer, he is entering or he is arriving on the continuous scale on 14.6 minutes, but the ATM will be free only after 15.4. So, the sixth customer may get the service only at 15.4 minutes. So, he has to wait for 0.8 minutes, that is 15.4 minus 14.6. He will use it 2.4 minutes. So, his completion time will be 17.8. The time in the system is 17.8 minus arrival time, that is 3.2. Like that, I have repeated for all 10 customers. Okay. Now, you see that total waiting time is 11.2 minutes. There are 10 customers. So, the average waiting time is 1.12 minutes. But what was our requirement? The average waiting time should be less than 1 minute. For 10 customer itself, the average waiting time is 1.12 minutes. Okay. So, how much time it is taking? 26 minutes for all the 10 customers. Okay. In the next slide, I will explain about the output measures of the simulation. So, we can compute an average waiting time for 10 customers. Okay. What is that? Total waiting time is 11.2 divided by 10, it is 1.12 minutes. Average time in the system. So, 32.1, how we got this 32.1? You see that this 32.1 divided by 10. So, the average time in the system is 3.21 minutes. So, each customer is spending 3.21 minutes in the system. Table shows that 7 of the 10 customers has to wait. How it is? How many people are waiting? This 1, 2, 3, 4, 5, 6, 7. So, out of 10 customers, 7 customers are waiting. The total time for the 10 customer simulation is given by the completion time of 10th customer. So, what is the completion time of 10th customers? 26 minutes, this one 26 minutes. However, at this point we realize that a simulation for 10 customer is much too short a period to draw any firm conclusions about the operating of the waiting line. So, what I am going to do in Excel, instead of 10 customers, I am going to repeat for 1000 customers. After conducting simulation for 1000 customers, then I am going to find out what is the average waiting time. I am going to test whether it is less than 1 minute or not. Now, I will go back to the Excel. Now, I am going to explain the idle time of an ATM. You see that what logic I have used for finding the idle time of ATM. If E21 equal to 0, that means if the waiting time is 0, okay, then the idle time, the waiting time 0 means that the customer directly enter into the ATM to get the service, but how much time that ATM is idle. So, that is C21, C21 is your arrival time minus the completion time of the previous customer, that is G20. See that the G20 is 15.4 and the arrival time of the 6th customer is 12.5. So, that many minutes the ATM is idle. Okay. So, that was the logic for finding the idle time. So, this I have replicated for 1000 customers. So, I will go back, I will come down, I will show for all 1000 customers. Now, you see the logic for number of people are waiting. So, E, see that count if E16 to E1015, if it is greater than or equal to 0, that is the waiting time is some positive. So, that many people are waiting. So, currently 642 people out of 1000 is waiting. So, what is the probability of waiting? 642 divided by 1000. So, 60% of the people are waiting. Then what is the average waiting time? So, the average waiting time is 2 minutes. You see that now you should remember here what is the expectation, what is the expectation of the management? The average waiting time should be less than 1 minute, but when we replicate it for 1000 customers, the average waiting time is 2 minutes. Then the maximum waiting time, how we got a maximum waiting time? See, maximum of E16 to E1015. Then utilization of ATM. Now, you see the formula for utilization of ATM, that is, so the utilization of ATM is the total time. What is the total time? That is G1015, that is 2509 minus sum of all idle time. So, that means that much time that ATM is busy divided by the total time. So, 80% of the time this ATM is busy. The next one, number of people waiting more than 1 minute. So, now I have counted how many times the people are waiting more than 1 minute. That means the 480 customers out of 1000 customers, 480 customers are waiting more than 1 minute. Then the probability of waiting for 1 minute is equal to So, that is E1023. What is the E1023? The number of people are waiting for 1 minute divided by 1000. Here we found the probability of waiting for 1000 customers. In other way also, we can find out number of people waiting more than 1 minute divided by total number of waiting, that is total number of people are waiting, that is 480. So, we can write this way, number of people are waiting more than 1 minute upon number of people are waiting. So, that is 0.6. But the very important summary statistics here is the average waiting time. Now, because now it shows the average waiting time is 1. So, if I press F9, for example, if I continuously press F9, you see that most of the time I am pressing F9, most of the time the average waiting time is more than 1 minute. So, I will go back to the presentation now. I will conclude saying that if you have only one ATM, you cannot achieve that service requirement of that customer should not wait more than 1 minute. So, here I have shown the formulas, Excel formulas for finding the different summary statistics. So, are we meeting the expectation of the management? What is the expectation of the management? The waiting time, average waiting time of a customer should be less than 1 minute. But just now we have seen most of the time the average waiting time for 1000 customer is more than 1 minute. So, we are not able to meet the requirement of a management. So, then if you are not able to meet this requirement, then we have to repeat this experiment by having 2 ATM instead of 1 ATM. Then we have to see again what will be the average waiting time if we have 2 ATM. That we will discuss in the next class. Some important comments here is similar simulation models can be developed by study the quality inspection at other production lines. So, we have discussed in the context of ATM, even in operation management context, here number of quality inspector is required, whether we need to have only one inspector or two inspector instead of ATM, that also can be studied. In each case, the assumption must be made about the appropriate inter-arrival time. What are the assumptions? What distribution it follows, inter-arrival time and the service time. This waiting line model was based on uniformly distributed inter-arrival time and normally distributed service time. One advantage of simulation is its flexibility in accommodating a variety of different probability distribution. For instance, if we believe an exponential distribution is more appropriate for inter-arrival time, this waiting line simulation could be easily repeated by simply changing the way the inter-arrival times are generated. Dear students, in this lecture I have discussed about the waiting line simulation. What example I have taken? A bank planning to have only one ATM and the service requirement is the average waiting time should be less than 1 minute. So, by having only one ATM, we have repeated the simulation for 1000 customers. At the end we found that we are not able to meet the service requirement. What is that? The average waiting time is always more than 1 minute. So, we have concluded that one ATM is not enough to meet the service requirement. In the next class, we are going to introduce a 2 ATM, then we are going to see whether we are able to achieve this average waiting time, that is less than 1 minute. That we will discuss in the next class. Thank you very much.